This is the walkthrough video for PCTC 2024 to 2025, round 1, Pathfinder, question 10, canoe slalom. So in this case, we're simulating a canoe slalom race, and we're given a map, and we need to figure out what path the canoeist takes following these rules. The first thing is easy enough. We're just inputting the map. So the map is going to be because we're going to list each line. So we're going to input each line and then list it. And we're going to do that for I in range as many times as our very first input, which in this case was 22. So now map should be a list of lists where each of those individual lists is each line. So now we need to do the actual simulation. So what we're going to do is, as we go down from the top row to the bottom row, we're going to modify each of these rows to show the path that the canoeist took, and then we're just going to print off the map at the end. So the first thing we should do is probably figure out where the canoeist currently is. That's going to be the first row of map dot index the hashtag. And so now we can start for line in range, and we don't actually need to do anything for the first line because that's already done for us. We do for a line in range 1. Actually, we might as well just do that. So yeah, so we might as well start from the first line because we're just going to overwrite the position of the matter. So for line in range, the length of the map, we want to do a series of steps for each of these things. So firstly, we want to make the current line. So we're looking at the current line, and we're taking the current index, which is current, and we're saying that is going to be equal to a hashtag, because at every point in time we are always going down vertically 1 from our current position. So we're always going down vertically 1, and so we can always be sure that this statement should be correct. Now the next thing we should do is probably figure out to see whether we are going through a gate or not. So let's create a variable called gate, and let's set that to equal to 0, and that means we're not going through a gate. And we should say that if a flag is in our current line, then gate should increase by 1. And we should also make sure that gate never surpasses 3. So what we're saying here is, if gate is equal to 0, we are not going through a gate. If gate is equal to 1, we have passed the first line of the gate, which is the flag. If gate is equal to 2, then we've passed the second line of the gate, which is the actual gate bit. And if gate equals 3, then we've finished the whole gate, and therefore we should restart and move gate back down to 0. So what this does is it says, if gate is equal to 3, let's shove it back down to 0. So just by doing this, our variable gate keeps track of whether we are in a gate, before a gate, or are done with the gate, essentially. And that can kind of go at the end of each of the lines. Now what we should do is we should say if gate is equal to 1, so if we have just passed the opening of a gate, now we need to actually now we're on the next line, so we actually need to do the going through the gate. So firstly, we should figure out what position that gate was at. So we should say pos is going to be equal to map of the previous line dot index wherever that gate was, which is that. And now we're going to do a different thing depending on if we are to the left of the gate or to the right of the gate. So if you are to the left of the gate, so if current is smaller than pos, we're going to go from our position through to the other side of the gate. So we want to say for column in range, well, our current position plus 1, because our current position already has a hashtag in it. So our current position plus 1, our target is to go to the position of the gate plus 1, because we want to go through the gate. But because this is a range in Python, range will stop at the number 1 before your ending. So we actually want to do a plus 2, because we want to stop at pos plus 1, which is the position right after the end of the gate. So we want to do that, and for each of those, we want to take the current line, which is map line, and we want to take the column and set the symbol at that to be equal to the hashtag, because the canoeist is going to go through that. Now, in the other case, where our current position is bigger than the position, which is to the right of it, then we want to go backwards. And remember, according to the constraints, current will never be equal to the position. So in this case, we want to say for call in range, again, we want to start at current, but this time we want to start at current minus 1, because we're to the right of it, so we're going to go leftwards. So we want to go to current minus 1. Our goal is to go to pos. Again, instead of doing pos plus 2, we do pos minus 2, because we want to go to the left of the position. And we're incrementing in minus 1, because we're going to the left as opposed to the right. So we're doing that, and then the other line is the same as before, so let's just copy that and put that there. Awesome. And once you've done all of that, well, that means we've just gone through a gate, and so let's increase gate by 1, because we've just finished going through a gate. And what else have we done? We've also changed where our canoeist currently is. So current should be equal to whatever the latest call was. So whether the call was from there or there, we're taking the latest call and saying current is equal to that. Awesome. And at every stage, we also probably want to print off the updated map. So you should do map print off map line. But to make sure we print it out in the correct format, because right now it's a list, and the reason we have that as a list is that we could alter the individual characters at the indexes we choose. But we don't want to print it off as a list, we want to print it off as a string. So to do that, we can just do that, which is the unpacking symbol. So we're unpacking that list, and unpacking basically just takes out every element of the list and prints it off with a space between them. Now we don't want a space, so we have to add a separate parameter called sep, which stands for separator, and change the sep to nothing. So we're just making sure that there's no gap. So we're removing that space. And I guess another solution you could do is replacing the space with nothing. These both do the same thing. And now if we submit that code, we should hopefully have solved this relatively challenging problem. We didn't solve this relatively challenging problem. As a runtime error. This hopefully should be easy enough to fix because it's just a runtime error. So actually, let's just run the code on this sample input and see what happens. Some live debugging, it's very good. So list has no attribute replace. Okay, right. So in that case, you can't actually do this thing at the end. So I was lying when I said that. You actually do just have to do sep equals that. And now we should get 5 out of 5. Yes, awesome. And that rounds off the round 1 series, and good luck with round 2.